In a static world, real-time information is limited to the moment you ask for it. In a dynamic world such as ours, to stay real-time, data must be consistently updated with every relevant change. Data subscriptions enable your database to analyze every new piece of data as it comes in to determine which queries need to be updated and provide real-time information. This gives you the opportunity to be the first in line to see new patterns emerge in your data. For example, say you discover that for the last 2 weeks, the bulk of your users are coming in from Canada. You can add logic to your site to include the previous night's ice hockey scores. If they start coming in from Brazil, you can expand that logic to include football scores as well. You can adapt your product and outreach based on live updates to your data. Today, RavenDB CEO Oren Amy shows you how, as he takes you on a deep dive into keeping your answers up to date long after you've asked the questions. Feel free to ask questions by clicking the Q&A button at the bottom of your screen, and Oren will be happy to answer them throughout the session. Enjoy your presentation, and here's Oren.
Hi, everyone. Thank you for joining me this day. This is actually election day in Israel. Don't get excited. It happened all too frequently with us. I want to talk about subscriptions. And subscriptions are, I think, one of the most underrated features of RavenDB, primarily not because of what they are, but what they allow you to do. So let me try to explain. We have a query. And this is a query. In a query, you reach out to the database and you pull some data out. Easy, simple, and that's what you do all day with databases. It gets more interesting when you have a subscription. With a subscription, you reverse this process. Instead of you reaching out to the database and asking him, give me all of the orders whose status is pending, you're doing the other way around. You register the query with the database, and then you ask the database, I want you to give me the data as it comes in. Now, there are actually two ways in which it happens. The first way that you have to deal with subscriptions is that you run the query, you run this, and the server starts sending you batches of documents. Now, let's see why this matters. This matters because with the query, you start pulling the data. And there is a live connection. This is an HTTP request. There is a TCP connection behind it. And the server basically streams you all of the data as it comes in. Sorry, all of the data that it has. If you have 100,000 results for this query, then you're going to get 100,000 results. But the issue here, if you want to do processing for each one of those items, well, now this is a different matter. Now what you need to do, you need to process each item quickly enough that you won't delay the query. If the query gets delayed, come on, move over. If the query gets delayed too much, what happens? Then we start having items in the buffer, data from the server that sits in the TCP buffer. If we don't process that quickly enough, what ends up happening is that the server says, hey, no one, I'm sending the data, no one responds to that. I think the other side is dead, and I'm going to abort the connection. So with a query, especially with big queries, you have a time limit. With batches, with subscriptions, it goes the other way around. You're going to the database and tell it, hey, I want you to give me the results of this thing. And I want you to do that in batches of specific size. And just, it sounds simple, and it is simple, but it's basically really, really, really stupid change. I'm sorry, I really don't know how to express that in any other way. It's a really stupid change. By being able to say, hey, when you give me the results, here we go, you can see how it looks here. Give me the max documents per batch, and you can set whatever you want here. And the idea here is that now Raven will send you 4,000 documents, and you get as much time as you want to process them. You can, by the way, make it 2 documents or whatever number you want, obviously. And when you're done, you're going to acknowledge this batch, and then RavenDB will send you the next batch. So that's interesting all on its own. But it gets more interesting because instead of dumping all of the data at you all at once, you're going to process that in easy to digest batches. But it's also interesting because what happened when all of the orders whose status is pending have been processed by my system? Well, at that point, you're not stopping. At that point, you're waiting, and the database is waiting. And the moment there is another document, be it a new document or an updated document, that match the query on the subscription, you're going to immediately get that. So think about what this means. Not on handling a lot of data, but handling all of the data over time. So instead of having a daily process that, oh, give me all of the orders that changed today or something like that, you can have it run immediately. Either you can run it on an ongoing basis, or you can run it, once a day and not have to worry about the logic of all of the record scenes, and this is complex, and you have lots of state and other stuff like that. And the fact that this can be offline or online. Offline in the sense that, oh, I'm going to run it once a day, process everything since the last time it shut down. Or online, just keep my client open, keep the subscription connected, at which point, whenever I get any document, I get to process that instantly and immediately with latency that is measured in milliseconds. Think about what this means in terms of business processes. In the intro, we mentioned that, oh, you have someone from Brazil, let's give him some football scores. That's actually one of the main benefits that we have for subscriptions, because subscriptions don't have to be part of your system from day one. In fact, a lot of the time, the way that you would best use subscriptions is whenever you define a new business scenario. Instead of trying to code it in your application, you're going to create a subscription and create a client that would connect to this subscription and start processing things. There is an architectural principle that is usually used when dealing with application code. This is called the open-close principle. And what it basically states is that you should be open for change, but closed for modifications. So open for change means that you can add additional behavior to the system, but closed for modification, you don't have to modify existing code. And that's important because every time that you modify existing code, you may introduce bugs, you may have to work on complex integration, stuff like that. In the context of something like adding local taste to whatever we're doing to the system, from the point of view of my system itself, I need to provide, here is some latest news that you might be interested in, which might be some array in a document or something like that. Once we have that, then we can have the subscription run in the background based on logic that we control, and the admin can modify it anytime. And then it's going to run, do its thing, and throw that data into the location that we specified, this array of interesting data for the user that we can now show to them. And think about it, I have no idea where you're going to get football scores, but presumably that's something that you can do. So I don't need to think about it right now. I can just run it as a completely separate process at some other time. I can detect, oh, I see that this guy is really interested in, I don't know, cryptocurrency. Here are some cryptocurrency pricing, stuff like that, cryptocurrency news. What currency is Elon Musk is currently investing in, those sort of things. So the fact that I can do that by just adding additional subscription and the behavior on top of that give me a lot of power. Now, I'm not going to tell you how to build your own system. That's relatively complex, but I do want to give you some taste about how that actually works. So let's see how subscription actually operate. Subscriptions are interesting. They are running on the server side. They are the server's responsibility. As a client, I connect to the subscription and start processing. So there is a very clear division of responsibility. The RavenDB server, or the RavenDB cluster to be more exact, is the one that is sending the results. The subscription client only needs to process that in some manner. Now, this is interesting because it frees you from a lot of concerns. Subscriptions are also reliable. And that's a really, really interesting distinction. It means that if you fail mid-process, the server will send you the documents again. If the server failed, you have transparent failover. Everything can fail, and this happens completely transparently. So for that matter, I don't even have to be connected to the subscription to get results that happened when I was offline. I can just run it immediately whenever I want, and it would start from the last place I was at. So basically, we assume that everything will fail. This node fails, this node fail, the client fail, whatever you want. In a world with for failures, especially if you run in the cloud, you know that stuff happens. Just this week, so just in the past 2 weeks, we had Oracle DNS causing global outage. We had GCP, I'm talking about Oracle Cloud DNS. We had GCP who had another DNS outage. Azure managed to mess up the keys and lose Active Directory. OVH had 4 different data centers go offline because of a fire. And according to the last time I checked, which was a few days ago, some of the servers are never coming back. Some of the servers are still not coming up. That has a huge impact. Failure is a fact of life. And those are just, the things that made the international news. Every couple of days, we receive some message from Amazon or Azure. Hey, the hardware running this instance so-and-so is experiencing problems. We're going to shut it down in 3 days. Failure is a fact of life, and you don't want to be the one holding the bad end of the stick in order to handle that. That's why I like subscriptions so much, because the infrastructure takes care of a lot of that for you. And the subscription just work. You keep processing documents and running them, and processing documents, running them, and you don't really have to think about that. Now, let's talk about how this actually works. A subscription has a state. For that matter, we can look into that. Here is RavenDB, and I'm using the live instance, and I want to go to ongoing task and define a new subscription. From orders will ship to city is London. And it did not find something. That should have, oh no, sorry. Wrong database. Now I have some data here. And you can see this is being shipped to London. So now you can see there is no client connected, but the most important thing from our perspective is that we have this particular state, and this is where we should start processing documents. Think about like a bookmark in a page, in a book. This is the last document that was successfully acknowledged by the client. So let's talk about what this means. The way subscriptions work, you're going to get a batch of documents. You have some time to process them. Whenever a document, whenever you're done processing the batch, you're going to acknowledge that. Only then will we send you the next batch. This also explains how we can handle errors on the client side. Because if the client failed and reconnect, we just start from the last acknowledged batch. Last acknowledged document and send you a new batch of documents. This state is cluster-wide. This has a couple of impacts. First of all, it means that subscriptions will only work if you have a majority of the nodes up and running. And the second thing is that subscriptions are, you don't need to worry about, oh, I got some data from this node and then I fell over to another node. I'm going to skip or repeat or something like that. All of that state is going to be persistently safe. Now, another thing to understand is that document change update this value. So we have this guy, A1739. Let's try to look it up. And okay, it's not this one. Okay, I can't find this here. So let's change something here. And now you'll be able to see that this change, and we have 28, 1, 2, 3. This is probably the one that we care about. 8, 4, 2, 4. Let's try it again. Here, 8 to 5, 8 to 4. So this is the value that change. If I'm going to look here at the status of this, what is effectively going on, I'm going to scan through all of the documents in the order based on their change vector. And the change vector is modified whenever a document is updated. In other words, effectively I have a pointer to the changes in the documents. And this is here where I have the document that already acknowledged. It was modified, so it goes here. And as I go through the batches, I will see it again. That's a really important factor about subscriptions. Every time a document is modified, you will see it again. Now, let's look at the client side. For the client perspective, you're going to get a subscription worker, and then you're going to call run. And then then RavenDB will call this Lambda, with a batch of items each and every time. You can see that I can open a session, do a whole bunch of modification, call save changes, and this is done. And this is quite interesting because I'm modifying the data that I have while I'm running that I got from the subscription, which means that I have to be aware of infinite loops. In this case, the order status was changed. If you remember, we're only getting status is pending. So the fact that we modify this document, we will not see it again. But this is absolutely something that you have to take into account. Another thing to consider when looking at this is that you want to control the batch size, you want to control other things that you have, but you have a session here. You can do whatever you want in terms of RavenDB operations. You can say, hey, I want to load related data. Hey, I want to modify some other stuff, a whole bunch of other stuff like that. And things are just going to work for you. Another thing that is really important, beyond just the loop factor, is that batch times can take a long time. Consider the case that I'm running some machine learning prediction or contacting some background API, some external API or something like that. I just got, 512 documents, and each one of them is going to be a separate request that takes a second or two to process. That's going to take a while. But we don't care. There is a heartbeat going on in the background to make sure that yes, I know I'm still processing this thing. Don't worry about that. And we're going to hold the state of the system in limbo, basically, until the batch is acknowledged. Now, I'm saying batch is acknowledged a lot. What does it mean? A batch is acknowledged if you exit this delegate without throwing an exception, which we also talk about the meaning of error handling with subscriptions a bit later, but the basic idea is that you complete this without an exception, the batch is acknowledged and will be processed successfully. Another thing to also consider, I'm running this thing as a sequential set of operations. It might actually make sense to say, hey, you know what? I'm going to want to issue, let's say that I need to go and talk to some other system. Let's issue a whole bunch of operations in parallel inside this code. And in C#, that's very easy to do. And the reason this matters is that you're not constrained in what's going on here. The only thing that you have to do is, how do I, if I'm letting an exception escape, that means that I'm going to abort the batch and I would have to rerun it. By the same token, if I'm starting some asynchronous work, that means that I'm going to have to wait here until that work is done. Otherwise, RavenDB will say, oh, you acknowledge the work by exiting this delegate, and we send you the next batch immediately. Okay. Right now, there could be only a single client connected to a subscription. And that means that you're guaranteed that the data will be processed in the order it was modified. There is no concurrency on batches and all sorts of stuff like that. In practical terms, it means that when you open the subscription, we can see it here. There we go. There is a subscription open strategy, and there are three of them: open if free, take over, and wait for free. The default is open if free. And in this mode, if no one is currently listening on the subscription, the first client to come in will get that. All of the other clients would abort. You also have wait for free, which means that it's okay if I'm last in line. I'm going to basically just wait until the other client or clients are done, and I would be the one who process the operation. Why do I have something like that? Because you may want to have reliability. You may want to say, oh, I have 2-3 nodes that are processing subscriptions. And some of them are going to win, and some of them are just going to be there pending for the first client to fail over, and then I can continue operations. There's also takeover if you need to. It's tends to be very early use. In terms of messaging patterns, we implement the at least once model. So we guaranteed that you will always get the result and you'll acknowledge them before we move on to the next stage. That also means that if you have a poison document, something that causes you to fail, you have to have some way to handle that. Because RavenDB will just keep sending it to you over and over the same document. We have a question from Ivut Debor. So I hope I'm pronouncing that properly. When you're calling an external API that could take a while, is it recommended to set the batch size to 1 so you don't have to start over again? I don't know. That's a really good question. Let's talk about how this can be done. So you have something like this, and I'm using Python because that's easy to play around with. But in general, you can run subscription in Node, C#, JVM, any supported client would make it happen. So one option is to do this, and I don't know, updates, and so we have something like this, and now if I'm doing something like this, well, that makes sense. And if I'm processing 1,000 of them, that would kind of sucks. So we can do something like this. By the way, this is probably not correct Python code. I'm not really that good in Python. So and here is another option. Now, in this case, we are doing it almost the same way as before, except that now we are doing this concurrently. I'm going to leave it as a task for you to figure out, oh, if most of the users, we can cache that or something like that. Doesn't really matter that much. Now, here's an interesting scenario. I can use this model. And let's say that I have the user for this. Something like this. As you can imagine, all of this is just notepad code. This is not going to work, but it should show you a good example. So what I'm doing here, I'm processing this, and I'm processing them in parallel. But here I'm saying, you know what? If one of them fails, I don't want to fail the entire batch. I want to process just this, and then I'm going to say, hey, refresh that. And then we talk about refresh in a little bit and move on. because I don't want this to be aborted. So you have a lot of options on how to handle that. And a lot of that depends on exactly how you want to control what's going on with your system. If you have more specific questions, if you can give me a scenario, we'll be very happy to go over that in detail. Okay, so as I mentioned, in terms of messaging, in terms of messaging systems, at least once is what we implement. We also have two modes in how to handle when there are no more documents to send. We can wait for the result, and this is great if you have, oh, I want to run this business process immediately, or you can close the subscriptions, in which case it says, oh, I want to process these subscriptions once every time frame. Another really, really interesting option that you have with subscription, especially if a lot of the more complex business processes happen there, is that you have the ability to temporarily shut down pieces of your application. Let's think about what this means. Let's say that most of my application is about the crowd operations, moving things back and forth from the web, the front end, and the business logic is handled through subscriptions. And this is a very common pattern. This gives me quite a few benefits. On the one hand, it means that I don't really have to think about, oh, wait, I need to update some of my backend logic. Well, shut down the subscription client, replace, update, run. You're done. There's nothing else to do. It also means that I have a chance to reset the subscription. Remember, I can go here and say, go to the beginning of time and send me all of those documents again. What does it matters? It matters because you're getting to rerun logic on stuff that already happened. And that can freeze you to do tremendous things. Oh, I had a bug in my code. I can just say, okay, let's run the same process on the updated with the updated code on everything that happened for the last 2 weeks, or from the beginning of time, or stuff like that. And that is tremendously freeing in terms of operations. It also means that, oh, my system is currently being hit because everyone went into Hacker News and Reddit, and I'm being swamped with users, which is a really, really good problem to have. But I'm running the system on a Raspberry Pi. By the way, this is a Raspberry Pi 400. I really like that. This is a real system that is running as inside the keyboard case. The nice thing about it is that this is actually allow me to run RavenDB, and on a terabyte scale database, I can hit latencies that are absolutely insane. If I'm querying by user ID, I can do 7,500 queries per second with latency of under 100 milliseconds on a Raspberry Pi. Now, if you have more complex things, stuff like that, then the more complex you have, especially write, because this has, I tested that on external USB key, you're not going to be very happy with that performance. You can only process something like 500 per second, 500 per second before you start seeing unacceptable latency of half a second or so per request. But the reason this is interesting is that when you're running your code, when you're saying, okay, I'm starting to see a lot of users coming in and I need to do stuff about that, you can shut down the subscriptions and nothing will happen. Your code will not run. The changes that you need will not happen, but part of the logic of such a system is that you pushed as much as possible of the behavior of the system into asynchronous background operations. And that's by design. So that means that, oh, if there is higher latency to processing orders, well, you know, this is Black Friday. You expect to have higher latency for that. Once the load is gone, you can start a subscription again, and they would churn through the backlog. For that matter, you can also leave them. And if previously if you have, oh, this subscription can process 3 orders a second, but now you have 30 orders that are coming in. If you're using traditional systems where you must process the order immediately, then that's going to kill you because you're going to have too much to do all at once. But the subscription is just going to run things and process them, and everything is just, okay, it's going to take some time, but it's still running. And as you see here, you have the ability to process things in parallel inside the same subscription. You do have to think about what this means. Do I force everything to go through? Do I have some error handling inline and stuff like that? Another thing that it is important to understand is that subscriptions also, basically, I mentioned earlier that they track changes. But what happens if I have 10 changes happen before the next patch? I'm going to get the last state of the document. Remember, this is where I am, and the document was here, and it was modified. When I'm going to get to it, I'm not going to get all of the items in the middle. I'm going to get just the last item. So you're guaranteed to get the document at least once, if after it was modified. But if it was modified multiple times, you're not guaranteed to get it multiple times. And for the most part, this is what you want. If you do want that behavior, you can use the revisions features. Let's see how that looks like live. One second. Well, okay. So now here's the current, and 1, 2, 3. 1, 2, 3, and there's some changes between them. Let's do this. This is this, and this is the previous one. Okay, so this is just a change to the change vector, not really that useful. Let's go and hopefully find something more interesting. But basically, whenever there is a change, okay, this is probably because we import the data. Let me do something slightly different. Orders, not this one. This is smaller. 555. Okay, now I can go here. Let's see that. And what I want to do is I don't remember how we do that. Let's see this, and I'm just going to scroll to everything. Great. I have a lot of those. Yeah, so much fun. Okay, let's try this, and I try to remember. Where is that? Okay. Metadata. I don't actually know if that would work. I messed something up. Yes, like this. Okay, so it doesn't like me. But the basic idea, sorry, I'm doing live demo on this thing. Apparently, I'm not doing that very well. The basic idea is that I would get this and this. So this is what I wanted to show you, this sort of difference. And I'm getting both versions, and I can run any sort of logic on that, including, for example, in my subscription, show me where the current and previous data change for some reason. Now, why does this matter? This matters because it means that A, if the document was modified 10 times, I will get 10 results. And if there is deletions or create, it shows up as null in the current and previous versions, respectively. More importantly, it means that I now have the ability to ask questions about the changes in the system. For example, this is the simplest example I could think of. Okay, how does this work? Move with show me orders where the country change, because I need to maybe recompute VAT or something like that. Okay, this is how you consume revisions from code. The only thing that you need to do is just say, I'm going to get a revisions of orders. And the rest of that is pretty much the same. I spoke extensively about error handling, but there are several types of errors that we have to consider. One of them is connectivity errors. The server is down, the TCP aborted, all of those sort of things, and they are completely handled by RavenDB, both the client and the server. And we have transparent failover in place and all of those sort of things that you can basically just ignore that. If the logic here throws, that is something that we call subscriber error, and by default this escapes an exception that escapes this delegate would abort the batch and not acknowledge that. There is a setting you can control to say just ignore that. I strongly recommend not doing that. And really important is that exception will abort the entire batch. It makes sense because we have no idea what you're actually doing here. So just abort the entire batch, and for the most part, for transient errors, just retrying would be good enough. Going back to the example of talking to some external service, if I'm trying to get the football scores in Brazil and they're currently having, I don't know, a big game and the server failed, then I can retry it later and it would work. And that's typically what you do. Here is a good example of proper error handling with subscriptions. And in this case, you can see, okay, I'm running, doing something here, but those are non-recoverable stuff. Database doesn't exist. The subscription does not exist. A whole bunch of other stuff like that. You're not authorized to the database. There is nothing you can do about those. You can just throw it away. Those things are interesting because that is where either I tried to connect to the subscription, but someone else has already done that, or the admin has decided to close the subscription. This can be because someone else with takeover tried to do that, or because the admin just say, hey, I want to shut this down. And you can see that the rest of the code here is basically, I'm going to keep track of the last 10 errors. And if there are more errors if there are more than 3 errors in the last 3 minutes, then I'm just going to throw. And that's about it in terms of a pretty robust error handling strategy. Now, I mentioned usage scenarios about business processing, backend work, and it's basically that. And you can do pretty much anything that you want here. And I want to emphasize again that if you move the system, your system, to have logic in subscriptions, then you have a more scalable systems because the user interface is already expecting asynchronous work, which means that, there is all the system, then the subscription is going to smooth it out instead of having to handle a spike of traffic. In general, RavenDB can handle a lot of load on the system, but RavenDB is typically not the only component that you have. So by saying, okay, I'm going to throw data into RavenDB and then I'm going to process that out, you are utilizing RavenDB to its full ability. Because, I want to write, I don't know, 3,000 or 30,000 documents per second, and then process them using subscription, it will just work. And RavenDB can handle those sort of numbers without really thinking about that. I also like to talk about commands, and this ties a little bit to what I were talking about before. In some cases, you just have, okay, I'm saving a document, an older document, and I know that, it's in pending state, so I need to process that. So that's one way of doing that. Another way of doing that is to say, hey, instead of doing that implicitly, let's create a ship order command. And then I have subscription on the commands, operate that, run that, typical message-based systems, and all of that. You get reliable processing, you get a least months execution, all of the usual things that happen. Another thing that I want to talk about is RavenDB is going to run a single subscription at a time. So if you have multiple concurrent subscriptions that's going to try clients that are going to try to talk to the same subscription, only one of them is going to be active at any point in time. This is actually something that we are looking into changing, and we expect in the next few months to have the ability to have concurrent subscriptions. So that would mean that in addition to, you would be able effectively to say, hey, let me just throw more subscription clients to handle the additional load. The downside of that is that you're going to have less guarantees about orders, and it makes some things more complex from our side, but that's why we build those features and not let you handle them directly. So concurrent subscriptions are coming and interesting. At the same time, other things that you can do with subscriptions that are quite interesting is you have data flow that is going on. So you can say, okay, I'm going to write a subscriptions. I'm going to write a document into a RavenDB server somewhere, and then have it flow through ETL or application to another location where this is handled. I mentioned that we have users who are running on edge locations. So it's very common for them to want to run it's very common for them to want to run, to write an operation here, flow that into the cloud, and then a subscription here is going to execute that. So this is effectively using RavenDB for distributed pub/sub, distributed command processing, and all sorts of stuff like that. Earlier, I've shown you this and this thing. And this is a really, really important feature that is really relevant for subscriptions. You can see it here. You have document expiration and you have document refresh. Now, the question is, what does this mean? And what this means is that with document expiration, RavenDB, if you have this enabled, RavenDB will automatically delete a document after the expiration have passed. With refresh, it does something slightly different. With refresh, when this has passed, it will remove the refresh from the document. This has got to be the most useless feature ever. Let's enable that and let's see what we're talking about. So here we go. And you can see that they have this refresh, and in about a minute, RavenDB is going to notice that, hey, this is a document that should have been refreshed already, and it's going to go to this document, edit, and remove this line. Why would we want to do something this stupid? I mean, it makes very little sense to want to do something like that. And the answer is very simple. This caused the document to be edited, which means that it would be again the target of the subscription, because remember, it was modified, so it moved from here to here, then the subscription is going to process that. So the idea here is that you can say stuff like this. Hey, oh, and you can see that this happened. And the document change vector has changed. So the subscription will pick it up. So now you're able to do things like this. You're going to say stuff like, and as oh, that's how I should have done it. Like this. Or, yeah, like this. And you give me nothing. Okay. See, like this. There we go. So what I'm saying here is that effectively, this is the backbone of saying, hey, I don't want to see those documents until the refresh duration have passed. So in this case, oh, I got an error. I want to reschedule running just this document in 3 minutes. This is what this means. This is a very, very powerful ability. Okay. We have Finn O'Mahony. I'm hoping I'm pronouncing this properly. How much data is too much data, and what to do with all data? Well, the question is, what are your requirements? RavenDB would work just fine to the terabyte range. If you have a 10 terabyte data set, I would say that's the upper end of what you want to see. If you have a 50 terabyte range, probably you want to split it up. And there are several ways of doing that. You can either split it up across logical boundaries, or if you have a good reason, you can do sharding. Sharding and server-side sharding is a feature that is coming to RavenDB in version 6.0. But the question here is, too much data, how much data is too much data is when it hinders your operations. And the question is, do you need to keep that much data? So let's look at something relatively simple. If you're looking at companies, so if you look at orders, not this one, let's look at this one. This order is from 98. It's already shipped. Do we care about it? I don't know. That's a business decision. For that matter, I can also say, you know what? I don't care about all of those details. but I do want to have the summary. You can use the time series feature to store aggregated data from tables that you're not interested in. Something that you can do is specify the expires feature, in which point you can drop all data automatically by RavenDB. You don't really have to think about it. And the question is, whatever this is something that you can live with. I don't think that it would be out of the question to say, hey, if the data is more than 2 years old, I don't care about it, I can delete that in some contexts. In financial systems, I absolutely want to have my data going back as far as possible, just in case the IRS decides to audit, or I need to look into, hey, what happened here, what happened there, and all sorts of stuff like that. At the same time, if I'm running I don't know, a website for a forum for university students to communicate with their instructors, the professor or instructors, then after the course is over, do I really need to keep the data? For that matter, after the course is over and 4 years have passed, they are out of the university very likely. Is that even really interesting? The assumption, by the way, in this case is that after the course is over, after a semester or two have gone by, then all of the data there is either super important and was moved to some other location. Oh, I gave you this amazing explanation of how to do, I don't know, a Fourier transform or something like that. So I'm not going to keep it there, especially not on a private forum. I'm going to throw it into some public location. But again, that's specifically for that scenario. If I'm looking at Stack Overflow, never want to delete any data there. So I'm afraid that the answer is going to have to be it depends. And with that, do you have any questions? Okay, we have first question. Arao Garcia, can I specify a change vector to start receiving the subscription from that? Yes, you can absolutely do that. And you can just take the change vector from here. And obviously everything that we're doing here can be done through the API. And here you go. And now it will start from this location. I mentioned before that I think that subscriptions are one of my favorite features. They are there because they are one of my favorite features about RavenDB because they are conceptually very, very simple, but the breadth of scenarios they enable is huge. They give you so much power to fingertip that is just amazing. I want to remind you, everyone, while I'm waiting for more questions, we have cloud.ravendb.net, and you can get started immediately. No need to do any credit card bill and stuff like that, and get your own live instance of RavenDB in a couple of minutes. We also, if you have specific question you want to do deep dive into your scenario, stuff like that, we also offer live demos, and we can talk to you about your specific issues and how RavenDB can fit into what you're doing. And Matthias, are there any features that you can already disclose? I already talked about two of them. One of them was sharding, which is coming in RavenDB 6.0. That's expected toward the end of this year. The other feature that I talked about was concurrent subscriptions, which is going to allow you to connect multiple clients with the same subscriptions in order to effectively process that from many locations. There are a few other interesting features. There is something called OLAP ETL that I'm going to just give you a hint on that. And I think you will like it very much. I'm not going to talk about this right now because I don't want to spoil the surprise. In general terms, we are expected to have the RavenDB 5.2 in about, I think, 6 weeks to 6 to 10 weeks, something like that. And that's going to contain some pretty new nice features and some enhancement to existing ones. Beyond that, the 6th version is what we are currently putting a lot of interest and attention to. And I think that the sharding being the big ticket items there, but there are also going to be some nice stuff as well. You can try look at our issue tracker, see some of the big stuff there. It's all open and available, but I think that's the items on the roadmap that we have right now. And Yvut, thank you for the clear presentation. Lots of possibility for the subscriptions. Yes. And thank you for coming here. Thank you for listening to me. And if you have any additional questions, feel free to contact us, ask us. We will try to be very approachable and give you all of the information that we have. And I think that's it. And with that, I'm going to go and see if the poll have closed yet. They haven't. They're about 5 more hours, and see what the status is. Okay, thank you very much again, and goodbye.